So next example. This one is different. This one's a bit more complicated because there's a variable in the denominator. The nice thing is, it doesn't matter. All we have to do is maybe a little extra bit of factoring, but the previous steps will remain the same. The only addition here, remember we can't cross multiply because there's 3 fractions. You have to have a fraction equals a fraction, so you can't cross multiply. We are still going to create a single common denominator so that we can eventually cancel it out, but we need to factor first. And the reason we need to factor first is because when we have involved denominators, so denominators that are more than just a single number, we need to figure out what the heck the pieces are that created these denominators. So all we care about are the denominators. 2m, well, too quick, sorry. Clean that up here. So m in the denominator here, negative 2m, m in the numerator here, negative 2m in the numerator here, 2m minus 3 in the numerator here. And I'm going to try to factor the denominators. So this is what I'm going to do now. I'm going to factor my denominators. I didn't bother factoring the numerators because there's honestly nothing to factor, but the denominators, they seem to have some common factors. For instance, my first denominator has a GCF of 2, leaving behind m plus 1. My second denominator has a GCF of 4, leaving behind m plus 1. My last denominator doesn't factor, so I'm going to leave it in black. So now that I see my pieces here, you can actually go ahead and say, oh, hang on, 2 and 4, those are going to reduce. Let's make my numbers smaller so I don't have to have as large involved fraction. 2 and 4 will reduce to 1/2, right? 2 divided by 2 is 1, 4 divided by 2 is 2. So now I've got m over 2 times m plus 1. I've got negative 1m over 2 times m plus 1. Dang, I'm really close. Plus 2m minus 3 over m plus 1. So if you notice, this is the only denominator that doesn't match. So let's give it what it needs. This denominator, m plus 1, needs a 2 to match the other denominators. Do they all match? If they all match, you can cancel them out. That's the beauty of this process. Matching denominators in equations. All right, this only works if they're equations. Matching denominators in equations cancel out. I'll say matching all denominators in equations can cancel out. So all that I have to do to solve this problem is solve the tops, solve the numerators. M equals negative m plus, distribute my 2, 4m minus 6. So let's combine some like terms. M equals 3m minus 6. So I'll subtract 3m. I get negative 2m equals negative 6. Divide by negative 2, divide by negative 2. Oof, almost to the bottom of the camera. And m equals 3. So again, the process, create a single denominator. But we do need to factor first. The reason we had to factor first is we had to figure out what they need to be the same. Once we figured out what they need to be the same, 2m plus 1, 2m plus 1, 2m plus 1, then we can cancel out all those matching denominators. Once you've canceled out the matching denominators, it's all about solving the tops, solving those numerators.